Here we are in the makecode.microbit.org site, and I am going to start out with the forever block, just in order to get my code started and test it. Remember, from the project criteria, you're going to need an on and off switch. So you're going to have to change this forever block. But for now, I want to introduce some of the things you'll need from the drawers that we haven't seen before. So you are going to need to access the pins from the pins drawer, which we looked at last time. And then the other thing that you're going to have to access is from the logic drawer. We are going to have to deal with some logic. And logic in coding is when you are asking a question and the answer is either yes or no, or, as most often the case, true or false. Is it true or false that a certain condition exists? Now, our condition, since we are going to use the light sensor that came in your box, the photoelectric resistor or the photocell resistor, this is what reads light levels in a certain space. And we are going to have this light sensor inside of our box. And that is what is going to trigger our alarm, the level of the light in the box. When the lid is open, that lets the light in, that sets off the alarm. So that is our challenge in the coding. And we need to connect that sensor up to a pin. And then we need that pin to read a level of light. So I have to be able to tell whether it is true or false that a certain level of light exists. So that's what we are going to need. So in the pins drawer, I'm going to need to be able to access pins, and this is from our vocab, pins that will read, that is, take information in from the sensor, and pins that will write, that is, pins that will let the microbit send information out to an alarm of some sort, whether you're going to use the speaker or what is sometimes called the buzzer, or whether you are going to use lights as your alarm. And so I want to have a read pin, something that is taking information in, and we have choices, digital or analog. And again, if you remember from the vocab sheet, that analog means that the values are in a range. So that's what we want, because the light is going to be different in every space. We want our sensor to be able to read a range of light, not just one or two specific light conditions. So we're going to get an analog read pin, and we are going to also need a write pin. Now, if you're going to use the lights or if you're going to use the speaker, those are digital. Those are on or off. So you're going to pull out a digital write pin. The other thing you're going to need is, again, that logic piece. If something is true, then do something. We can either have that do, if it is true, then do one thing, or if it is true, then do one thing, otherwise or else do something else. And I'm going to grab this block right here. Now you can see that these blocks fit puzzle piece wise into these spaces, but this block does not. I've got to find a place to put this block. And this digital read pin, it needs to be associated with a value. And that value is going to be part of an equation. So notice where it says if true, and it's got this polygon shape with points on the ends. What we are going to do is find one of those. And again, I'm going to go to the logic drawer, and I'm going to look at these down here and notice that these are rounded spaces. I'm going to pull, and I'm going to pull the one with the greater and less than symbol. And I am going to take my analog pin and I'm going to fit it into here. Now, this is letting us set up that logical condition to be either true or false. If the pin that is reading the light is getting something that is greater than or less than a certain level, well, then that's what we want the alarm to act on. Now I can set all of this in here, so you can see what these look like. If the pin with the light sensor is reading, and I have mine set at pin 0, then, and it's less than, and I'm just going to start by choosing a number. Now, let me say this about the hardware, about these sensors. They're all a little bit different. And also the light bulbs you have in your house, the amount of light coming in windows, all this makes a difference. And you're going to have to play with these numbers. This is a project where you're going to have to do a fair amount of testing to get your numbers correct. So I suggest that you do not build anything into your light box yet. Simply do the code, and then in the next part, we will test before we actually build. We are going to look at a number, and in the text for Project Lead the Way, it says start at 750. I've never started that high. These ranges go all the way up to like 1135 or something like that. I'm going to just start at 100. And if the light is less than 100, then something is going to happen. Otherwise, something else is going to happen. Now, if the light is less than 100, that would mean that the box is closed. And I want everything to be cool. So digital write, and let's say my alarm is set to pin 1, well, then the digital write pin 1 is going to be 0. It's going to be off. Now, I'm going to make a copy of this. Duplicate. And otherwise, if it's not less than 100, meaning it's 100 or greater, then I want this to be on. I want the alarm to go off. So what my code here is telling the microbit is that I'm reading light on pin 0. If it is less than 100, keep the alarm, which is hooked up to pin 1, off. Otherwise, set the alarm on. Now, let's look over at our emulator and let's see if this works. So forever, 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 it's reading. And notice there's little zeros now next to these pins. And what that means is I can place a value in these pins. So right now, it says 0 next to pin 0. And if I mouse over, that is analog in. So I'm going to raise, I'm going to click and raise the value. Notice what happened. Once I got above 100, it activated pin 1. So below 100, pin 1 is off. Above 100, pin 1 is on. And you can saw that it changed from 0 to 1. So according to the emulator, my code is now working. Now, this is as much of a hint as I'm going to give you right now. It actually is the basis for your code. The next thing you do is put this together in the microbit and test it.